Hello everyone. So let's learn some basic rules of differentiation today. Some basic rules are the differentiation of constant value is 0. The differentiation of x to the power of n with respect to x is n x to the power of n minus 1. Differentiation of e to the power x is e to the power of x. Differentiation of log x is 1 over x. Differentiation of a to the power of x is a to the power of x log ea. Differentiation of sin x is cos x. Differentiation of cos x is negative sin x. Differentiation of tan x is sec square x. So you need to know these basic rules to apply the further rules. So we're going to learn three rules: product rule, quotient rule, and chain rule here. So let's focus on product rule. If we have a function which is a product of two functions, let's say we have y, which is f of x times g of x. So there are two functions. So when we differentiate with respect to x, it will be dy over dx. By using product rule, how do we differentiate? So we write the first function and then we differentiate the second function, plus we write the second function and we differentiate first function. The order is not important in the product rule, so you can differentiate any of the function first and the other function later. For example, how do we apply? Let's say we have y is equal to x to the power of 3 e to the power of x. Now, there are two functions, one a cubic function and exponential function. So by product rule, by applying product rule, we can write dy over dx. This is x cube. First we differentiate e to the power of x plus e to the power of x, and then we differentiate x to the power of 3. As we know by the rule, the differentiation of e to the power of x is e to the power of x. So it's going to be x to the power of 3 e to the power of x plus. The differentiation of x to the power of 3 will be 3x squared, and we haven't differentiated e to the power x here. So what's common in both the terms? It's x square e to the power of x, and this is, so we get x plus 3, x plus 3, right? So this is the answer for the differentiation of this function. So whenever we have a function which is product of two different functions, or it may be three, then we can use product rule. And then we see quotient rule here. When we have a function which is in terms of quotient of two functions, it means y. Sometimes we also call it a rational number, and g of x shouldn't be 0. So when we have a function which is in terms of like a rational function, and we can differentiate this by the quotient rule. By applying quotient rule, we can differentiate. So we can write g of x, and then we can differentiate f of x minus g of x, and then we differentiate f of x divided by square of g of x. Okay, it may sound confusing, so for simplifying, we can denote, if we denote f of x as numerator and g of x as denominator, so you can remember in this way, like you first write the denominator, it should be silent, and excuse me, and we differentiate the numerator here, minus, then we write denominator and we differentiate numerator, then we write numerator and we differentiate denominator. Okay, so first we always here we always differentiate the numerator first. The order in the quotient rule is important, the order in the product rule is not important, but here it's important, and then divided by the square of denominator. To understand this rule, we can solve a problem like we have a question e to the power of x over 1 plus log x. Let's apply quotient rule here and see how do we solve it. So that's dy over dx. So first we write the denominator. We are not differentiating, it's just silent here. And then we differentiate e to the power of x minus, and then we write the numerator without differentiating it, but we differentiate denominator, which is 1 plus log x, and then divided by this is 1 plus log x squared. As we know the rules of differentiation, the differentiation of e to the power x must be e to the power of x. When we differentiate 1, which is a constant, and differentiation of a constant value is 0 plus 1 over x, and this is 1 plus log x squared. So by simplifying we get x e to the power of x 1 plus log x minus e to the power of x over 1 plus log x squared. Or we can write e to the power of x, this is x plus x log x minus 1 over 1 plus, this is dy over dx. Okay, hope you must have understood. So first we differentiate numerator, we put a minus sign, and then we differentiate denominator, and in the denominator there will be square of the denominator. Okay, to get familiar with these rules we must practice more and more questions, and then we see chain rule. When you look at the books, you will find there are many types of differentiation like implicit function, like logarithmic differentiations, but all those type of functions, all those type of differentiation is possible when you understand these basic rule: product rule, quotient rule, and the third one we are learning here, which is the chain rule. So if we have a function f of g of x, so the differentiation of such function would be we first differentiate f of g of x times, and then we differentiate g of x, then we find the derivative of g of x. Okay, it's like, so this is basically composite function. So the chain rule is used to solve the differentiation of composite function, or you can say function under a function. For example, y is equal to sine x squared plus 1. Now sine is a trigonometric function and x squared plus 1 is an algebraic function. So here the algebraic function is inside the trigonometric function. So how do we differentiate? Let x squared plus 1, let u is equal to x squared plus 1. Now here we differentiate both sides with respect to x, so we get du over dx. The differentiation of x square will be done by the rule x to the power of n, which is n x to the power of n minus 1. So that's 2x. 1 is a constant value and the differentiation of constant value is 0. So we get du over dx, which is 2x. Now we have y is equal to sine u. Here we differentiate with respect to u and we get dy over du, and the differentiation of sine is cos. So that's cos u. To get dy over dx, we must multiply dy over du times du over dx. So that's cos u times 2x. U is x squared plus 1, and that's sine 2x. So we get the final answer 2x cos x squared plus 1. In the next session, we're going to practice more and more and different type of questions related to the product rule, quotient rule, and chain rule. Thank you so much.